Hi, this is a presentation brought to you from the IBM Champion community. This particular presentation is about IBM MQ messaging security, and it's a quick dive into that. So let's get diving. We're going to cover what is MQ, some basic security concepts that are applicable to all software, how those concepts apply to MQ, what is special about MQ and technology, some of the telecommunication implications there are for security, and how MQ deals with these, and finally we'll wrap it all up. But before we dive into the security aspects, some of you might be less than familiar about MQ and say, what is MQ? Perhaps that's why you're even watching this. In a nutshell, MQ is email for software programs. Rather than make a synchronous call, like a telephone call or a procedure call in a programming language from one piece of software to another, MQ provides asynchronous messaging, just like email. You send an email, the recipient gets it at some point in the future. You don't have to be directly connected to the recipient at the same time. The recipient reads it, you don't have to be around. That's asynchronous messaging. That's what MQ is, email for programs. So, on to MQ security. Some basic security concepts apply to MQ as they apply to all things. We have entities, that is people or organizations. For example, I am an entity. I'm Glenn Brumbaugh. My identity is separate from the entity that I am. I have multiple identities. I have multiple email addresses. Each one of those is an identity, but they map back to the same entity. So we have entities. We have an entity may have one or more identities. Given that I have an identity, let's say glenn.brumbaugh at us.ibm.com, and I want to access a resource, there are various operations I can perform on that resource: read, write as I/O examples, create, delete the entire resource, start, end in terms of operations, display or inquire, some supporting type functions. So there's different operations, and there's lots of different kind of resources. In MQ, we have we call a queue, which you can think of in email terms as a mailbox, and we have channels, which you can think of as a TCP socket. So we have entities, identities, operations, and resources, and the flow of security, which we're going to cover in the next slide. An entity will assert an identity. Someone will authenticate that identity. That identity will have a variety of authorizations to access specific resources, and that access should be audited. And you can see that kind of flow here as you have the assertion and the authentication, the authorization, some determination as to whether access is to be granted, and some auditing of that access. Security concepts as they relate to MQ. We talked about entities. The identity will be a user ID in most cases. That user ID will correspond to membership in some kind of group, and MQ does not grant access to user IDs. It grants access to groups. So that user ID group relationship is quite important. The identity also could be in an SSL TLS certificate. That's an X.509 standard certificate. It could also be that this is an MQ to MQ transfer, just like a email server talking to an email server peer, in which case you may have the originating server name or IP address, or in this case queue manager name, as the identity. You can have those different kind of operations we talked about: administrative, operational, I/O support, and you can have resources in MQ terms. Those resources are queue manager, channel, queues, topics, subscriptions, and processes. The security A's, as we call them: assertion, authentication, authorization, access, and audit. This is what it's all about. There is an assertion of identity. I say I'm glenn.brumbaugh@yahoo.com. That's an assertion. I may or may not be. Someone will authenticate that assertion and say, yes, you should trust that assertion. Once you have an assertion of identity, that identity can be checked for authorization for certain types of access to resources, and that access and that assertion can be audited. So we have the A's: assertion, authentication, authorization, access, and audit. This is basic security conceptualization. It applies to MQ as it applies to all other kinds of software. Some notes on authentication. How do we trust that assertion that the identity is asserting an ID? I can say I'm President of the United States. It's an assertion. It may or may not be true. How do you determine whether it's true? We can have an external security provider, LDAP, Active Directory in the Windows world, RACF, ACF2, or top secret. In the mainframe world, typically those work with secrets, which is normally a password. So I would assert a user ID and I would provide the secret associated with that user ID, which is the password, and that software would verify or authenticate my assertion. I say I'm user ID ABC, I provide the secret for ABC, and the software says, yeah, we trust him. That software could be external, as we just talked about. It could be the local operating system. You log on to your laptop, you assert a user ID, you provide the secret, that is the password, and you either log on to your laptop or you're denied. There are other mechanisms. Some of the laptops have fingerprint readers now, so there are keys. So there's multiple authentication methods. Some software will maintain lists of user IDs and passwords in the software itself. This is sort of a lighter weight, typically for dev or test environments to get things started quickly. Could be that the client provides a secret across a communication link, for instance, SSL TLS certificates. One note to be considered on authentication is how large that span of trust is. If I say I'm user ID ABC for IBM, does that mean that I should be granted access to every IBM facility everywhere in the world? There is some restriction to the authentication levels, and so I may be authenticated in one domain, let's say the United States, but not allowed entry in another domain, let's say United Kingdom, because those two areas have separate trust domains. And trust domains, it could be an LDAP domain, an Active Directory domain, different certificate authorities are trusted, lots of different domains. But the authentication of an asserted identity is local in scope to that domain. That domain can be big or small. Queue manager. That's the basic unit of MQ, a queue manager, just like a mail server. So that queue manager has some particular properties. Remember that MQ is serving software. So software has to connect to MQ, and it can connect in two ways. It can connect locally, that is, I am on the same machine as the queue manager, and that is called bindings mode. But it can also connect through a TCP socket, and that means I could be local, connecting through the TCP stack, or it could be on a remote machine connecting to a queue manager through TCP. That's called client mode. And those have very different security requirements, as we'll see in a minute. In bindings mode, the local process is calling or requesting MQ services from a local queue manager. That means the local process has been authenticated in the way that that local server authenticates, either the operating system or a remote thing like LDAP or AD. And it is the same mechanism used by the queue manager itself because they're both local. And so in essence, that's a trusted authentication system the queue manager has to trust it because it's the same authentication that's controlling the queue manager. MQ provides an additional mechanism called connection authentication, and it can say, even though you're a local process, which means that you must have authenticated to the operating system at some point to execute, I don't trust that it's still you. So when you want to connect to me being MQ, I'm going to ask you to re-authenticate locally again. And it's the same authentication process, whether it's Active Directory, LDAP, or the local OS. It's just you have to provide your credentials again, in this case, the password for your user ID. So for instance, if you walked away from your terminal and this was in place and somebody popped in and said, oh, I want to talk to MQ, you could set MQ to say, well, yeah, I know that you're logged on that machine, but you want access to me, prove it right now, and re-authenticate, a typical sort of window pop-up. In client mode, that's when we want to connect to a queue manager that may be local, but it may be remote. We're connecting through a TCP/IP socket. So MQ does this magic. Instead of calling the program, I send the request across TCP. I have to have the right library in my software, but MQ does this auto-magically in the background. However, my process is associated with a user ID on my machine. So let's say I'm calling your queue manager on your machine and I'm on my laptop. And I assert on my laptop that I am the President of the United States, whatever that user ID would be, and I send that request across the wire to you. Does that mean that you need to trust my laptop because I've asserted that I'm the President of the United States, and my local laptop says, yeah, you are that user ID. You provided me with a secret that goes with that user ID. Your remote computer may not trust the authentication and reliability of my computer because the provenance of that user ID, that asserted user ID, is unknown, right? If I assert my user ID here locally on my laptop and send this across the country to your computer saying, I am me, trust me, you may decide you don't want to trust me. And MQ has a number of ways to deal with this issue of distributed trust. This comes into what we said, that authentication domain. You may not trust how I've authenticated. We can use SSL TLS to do that, to say you have to pass me a certificate that I trust, and that certificate will have credentials associated with it. Within the certificate, it'll say this is your user ID, this is your organization. We can have rules, channel authentication rules, which are kind of like firewall rules. You can't talk to me unless your user ID is this. That doesn't authenticate it, but it says you have to claim, you have to assert that you're this user ID. I can say I'll only let connections in from certain IP addresses or certificates with certain properties. MQ provides the ability to extend this security and this filtering process by writing specific security exits. So you can do that as well with extra code, either written by yourself or there are third-party providers out there that provide some of these exits. And there's also, as we mentioned before, this connection authentication, which says, I don't really care who you assert you are, prove it. And so I want you to pass me credentials, that would be a user ID and password, across the TCP connection that I'm going to authenticate locally because I trust the authentication here. I do not trust the authentication performed remotely. So that's what connection authentication is about, kind of sophisticated. The TCP process for these kind of client connections coming across the network can be fairly complicated. You can see here, step one, we have an incoming TCP request. Then we basically say, well, is that address allowed to connect to me? That's a channel authentication rule. If so, I'm going to read the data from the connection. I look up some channel information. I perform some checks. I exercise some rules, again, channel authentication rules. Now I may call a security exit that may be blocked there. There's a number of steps that go through to get connected, and this is actually all happening after you would clear a SSL/TLS connection. So if this TCP channel required SSL, or TLS is the modern term for that. SSL is an obsolete technology, but we still use that term frequently. Just as we say a Xerox machine for a copier, people will refer to SSL when they really mean TLS. SSL stands for Secure Socket Layer. It's an obsolete protocol. It was developed by Netscape in 1998. TLS is Transport Layer Security, and that's what both of those protocols use X509 certificates, and TLS is what we're using now. All of the SSL or TLS connections processing would happen before step 1 here. So quite a bit can go on before that channel connection is let in. You can see here the flow through MQ security. If you come in as a client across that channel, you've got to clear your SSL TLS checks to get a working socket before it ever gets to MQ. If you've cleared SSL TLS, then we get down to a channel authentication rules. If you pass those, we can have those channel security exits. Now you can come down and be required to re-authenticate locally at this point, and that would be the same time as a local user coming in on bindings mode. He may be forced to re-authenticate as well. Those settings are configurable. Once you've gotten through that hurdle, all we have hopefully is an asserted user ID and therefore group, and nothing more at that point. And now we're going to say, can you actually have access to these resources that you would like to use? And we're going to go into the portion of MQ called the Object Authority Manager, which is your security component, which basically says, okay, I have an authenticated user ID at this point. What is that user ID authorized to do? And then the queue manager is going to pass that request ultimately to the MQ resource, let's say a queue here, so you could read or write a message. It's like reading or writing your email. And that email could be encrypted. And that's a component that MQ calls Advanced Message Security, which has the ability to encrypt it as it's written to disk and read back from disk. SSL TLS only encrypts as it comes across the wire. So this would, the combination of AMS and TLS would encrypt it over the wire and encrypt it as it's written to disk. There's quite a bit of operating components going on here in all this process. We have IP considerations as we come across the internet, TCP IP here. We have operating systems, may be performing some security role, will be performing some security roles, for instance, file system security, may be performing authentication. That may be externalized to an external security system, Active Directory or LDAP in the distributed world. And MQ has roles to play. And you can see that here in that there's operating system communication security, kind of one path into MQ. There's authentication in LDAP or external security that's blocking your path in. There's file system security, which is stopping you from getting to MQ resources because they're protected by the file system. And there's MQ components. The MCA, the MQ message channel agent, is handling the TCP IP communications layer security. The queue manager is handling that connection authentication, forcing you to re-authenticate. The MQ OAM is the Object Authority Manager, seeing that an authenticated user ID has access or not to MQ resources. And finally, that MQ AMS component is encrypting the stored data on disk. So quite a number of different components can be brought into play to make quite strong security. In summary, all of the basic security concepts are relevant to MQ. Identity, entity, access, resource, and the A's, assertion, authentication, authorization, access, and audit, all are relevant to MQ. MQ has some special technological implications because of the ability to connect to MQ from a remote location, either peer-to-peer, that would be queue manager to queue manager connections across message channels, or from a client interacting with their message server through TCP IP channels. And we have to handle those differences in authentication between local and remote if you come through TCP. And that's a picture of your presenter. It's been a pleasure presenting.